Hello and welcome back to my Kubernetes series. In this video I will walk through one of my deployments which takes care of submitting my ISP assigned IP address to my dynamic DNS provider duckdns. Why is this step necessary? If you have no fixed IP provided by your internet service provider, your external IP address could change. It is similar to your DHCP server at home. You log into your network through a device which gets its address assigned by this DHCP server. That address is allocated to your device for a certain amount of time. If you log in the next time you come back to that network, your same device could have a completely different IP address. That time is called lease time. Your ISP might or might not do the same for your external IP. And once in a while, when your lease time is up, assign a new IP address to you to make sure a dynamic DNS service is able to route the traffic that is destined for your services at your home. You need to submit your IP address on a regular basis. That is what we will make sure through the deployment. In this video, we will discuss how such a deployment can look like. To make this application work, I created my own container, which we are going to walk through next. The deployment consists of two files and an automated script. The automated script can be executed to build the container if there are security flaws discovered and make it really simple to re-upload it to the container registry. The files we will discuss in this video are the entry point sh and renew DNS sh. However, we will start with the automated script and walk through how this container is built. Building the container is really straightforward. I use Builder for any of my container builds. It was before Red had created this kerfuffle. It was easy for me to create scripts and automate the whole container building process, and I have not been able to migrate these scripts over to Docker. Please don't judge me. Moving on, I built the container through the Alpine latest. I update and upgrade the existing container without downloading anything to this container to make sure the size stays nice and small. Next, I add the bash and curl packages to this container, and then I copy the renew DNS sh and the entry point sh files into the root directory. Once that's done, I change their rights to make sure they are executable, both of those files, and I set the entry point of the container to the entry point sh in the root directory. Once that's done, I add additional labels such as the author and what it is being used for, and I commit to that container build. That builds my image, which I can then upload to any container registry. That is my first file, the automated script to build the containers. Let's quit this file and jump right into entry point. The entry point, as you can see, is very straightforward as well. First, it is a bash script, and it looks for the environment variables, user and token. If these two values are not available in the environment variables of the container, the script will stop and the container will crash. That is by purpose and by design. I don't want this container to run and not do anything, and I'm not noticing. However, if these two values do exist, a script is repeatedly run, which is the renew DNS, and we'll get to that in a second. The script sleeps for 5 minutes and then it repeats this step. that will make sure that my IP address is updated on my dynamic DNS service in a 5-minute interval. That is all that there is to this file. So let's quit and enter the renew DNS, which is slightly more complicated. Again, we have a bash file. Previously, I used a log path to store logs. So if you get an OK, then it was written to a file. However, as I'm running this container in Kubernetes, that is not required. I output that detail on the console. We'll get to that here in a second. First, I'll pull the user from the environment variables and the token. Then I have a URL which I assign to the URL variable here. And as you can see, it updates your domain with a username and your token that you get from duckdns. Next, I have a function which formats the output or the result from this update. At first, I have a local variable called message MSG, and it gets an information here. I'll show you in a second which information that is. It is the first information that comes back. $1 stands for that first information that's coming back. Time date, I format the time and the date. And then I echo this time and date in brackets, followed by a status, which is a string, followed by the message that is being provided by the calling script. And this calling script, all there is to it is the result. I curl k and add the URL, which means it calls my duckdns website with my user details, and it provides that external IP address to my duckdns service. Once that's done, it calls the logging, the function we just went through, and adds what the result of this query is. So once curl is run, you get a feedback, and that feedback is in the variable result. It comes to the logging script, and the message is the $1 or the result variable down here. That's what's being handed over in $1. And then I can output my message on the console. This script is run, as you've seen, every 5 minutes in order to make sure that if my IP address really changes, every 5 minutes I can make sure that my services are reachable within the next 5 minutes. As we're done here, I can quit. That is all there is to the container. Let us now head over to the Kubernetes deployment and walk through the 2 files we need to make this application work. At first, we're going to go into the KDS setup folder, and in number 7, the cert manager, show the replicator, and we're going to create mkdir here for duckdns. We're going to create a file called duckdns-deploy.yaml, and I'm going to paste the contents of this deployment that I created. Let's start at the top and walk our way down. The deployment, it's the kind deployment. Name is duckdns. Namespace was at the time test-duck, testing the duckdns service. I will change that in my main deployment, obviously, but we'll get to that. It has 1 replica, and we have a selector in here which has a match labels to it, and the app is called DNS Updater. The template is similar. It has metadata and labels, and the app is again DNS Updater. The spec and now containers, I call it my container. We're going to change that to duckdns updater. It does not need to align with the previous labels, but I do prefer that. Then we have the image repository, which is on quay.io. Again, please don't judge. I used it before all this kerfuffle with Red Hat went on. However, that's where it's stored right now. Quay.io, Real Shadow, duckdns. The image pull policy is always, especially for development containers, you always want to pull the latest and newest container that is on that registry, and you don't want to rely on what's being stored on your Kubernetes cluster temporarily. We then set some environment variables. We have one which is called user, and it's a value from a secret that is called duckdns token. The key that we're pulling here is user, and the optional false stands for this is a must. This container or this deployment will not start up if this secret does not exist, or this key, actually the key user, if that doesn't exist, this deployment will not start up. Next, token, very similar. The value is from the secret key reference. The name of the secret is duckdns token, and the key that we're pulling in this part of the secret or into the environment variables is the token itself. And again, this secret or this value is not optional. We declare ports on port 80. This was not necessary actually, which turns out, but I kept it in here anyways. I outcommented the volume mounts because I don't need them. I have volumes. I don't need to mount the volume inside of the container because I read right out of those volumes and add the details to the environment variables. It was easier than to write another script inside of the container. And then we have the volumes, and these volumes, it is a secret, and the secret is the duckdns token. And again, we have the optional false. We're going to write and quit this deployment. The next file we need is, well, fairly obvious, the secret. So let me quickly copy, and then we're going to create vim duckdns secret.yaml. And you will excuse that you will not be able to see the user as well as the token. Those items will be hidden in the final cut of the video. We have an API version 1, we have a secret. The secret name is duckdns token. Make sure that whatever secret you have, it's in the same namespace as your deployment, otherwise this whole thing won't work. It's an opaque. That means you can declare whatever key value pairs you want. And then we have a user, which is base 64 encoded. That is not a encryption. That's why it's also hidden from the final result. And then we have the token, and again base 64 encoded, which again is not encryption. This is the secret. As you can see, there's not a lot to it, so we're going to write and quit that. Once those two files are deployed, then the container will be run, and my DNS or my IP with my dynamic DNS provider will be updated. We will deploy these two items in a second, and we'll see what the output on the console of our container is going to look like. Before we deploy those files, let's take another look at kubectl get ns. We have the namespaces, and we still have that test namespace from our previous videos. So let's change the files that we just went through, modify the namespace, and then deploy those files in the namespace. But we're going to deploy the container or the deployment without the secret and see what happens if what I said earlier was true or not. And then we will deploy the secret and the container. And then both the container should be run and update my IP address. So let's start with the modification of the files. We're going to change the deployment first, and it's test namespace. vim duckdns secret. We're going to change that here obviously as well, if we remember how to do that. Test namespace. So those files are updated or changed. Now we will start the watch kubectl get all dash and test namespace. We have nothing in here yet that we can see, so let's deploy the deployment, the application without the secret first, and observe what happens. Kubectl apply-f duckdns deploy. The deployment is created. Container is being created. But as you can see, we get a config error. This is the by purpose or by design that I mentioned earlier. We do not have a secret. The user and the token doesn't exist, so this container would not be able to run anyways. But we get this output right here on the console, and we can fix the issue right away. So let us delete that deployment again. kubectl delete -f duckdns deployment. It's been removed. We will deploy our secret first. kubectl apply -f duckdns secret. The secret is created. Now we will deploy our duckdns app again. Container creating. And the container is already running. As you can see, the declarations we have in the deployment as well as in our file all work. The container crashes, or rather it shows as a configuration error because it can't find the secret. Once we deploy the secret, the container starts up just fine and works like it is supposed to. Now we will take a look at the console with kubectl logs. Let us copy that name. That's a little too much to write here. Dash and test namespace. And as you can see, or if you remember back a few minutes ago, we defined that output on the console, and one is the format of the date, followed by the string status, and the status is OK. That means our curl command reached out to duckdns, submitted our external domain, and the feedback that we got was OK. That means the updated IP was received and processed, and our service is uninterrupted, and we can access our deployments in our Kubernetes cluster from through the duckdns domain name that we have. With that, we are going to wrap up this video. What's working? This was the last video in our infrastructure setup. We have completed that part of our journey and our cluster deployment. We have a cluster with 4 worker nodes, a load balancer, an ingress controller, a certificate manager that will provide us with valid certificates, so there will be no browser errors once someone approaches that page, a certificate replicator or secret replicator, so we can use those certificates and secrets in other namespaces. And we have an updater for our dynamic DNS service, duckdns. What's left to do? In regards to our infrastructure, nothing. That part of our journey is complete. But of course, now the fun only begins. In the next videos, we will start setting up database, Nextcloud, Postfix, Dovecot, and a synchronization for phones. However, the kickoff will be the setup of a replicated database, namely the MariaDB Galera cluster, developed by Bitnami. The work these guys are doing is just fantastic, so I hope you are as excited as I am to get into the cool stuff with me. As you can see, there's something to look forward to in our next video. as we start the journey into the more visible pieces of this video series. Thank you again so much for watching, and I will see you in the next video.